Hello there and welcome to this video where we're going to take a look at a problem in mathematics that I've taken from a mathematics admissions test, or an MAT. So for those of you who are not familiar with the MAT, I'll just explain what that is. So here in the UK, if you're applying to university to do mathematics, computer science, or a mathematically related subject at certain high-ranking universities, as part of your admissions process, you may be expected to sit the MAT, or the Mathematics Admissions Test. And this will usually be prior to any interviews, and it will be usually based on the result that you get in the MAT will determine to a certain extent whether or not you get invited for an interview. I'm not saying that it's going to be all down to the MAT. There's other factors that are taken into consideration, but the MAT will be one of the things that is taken into consideration, the result that you get. So what should you expect on the MAT? Well, if you're doing A-level maths, then you should expect some problems to come up on mathematical problems to come up on the MAT that are typically a bit more challenging than what you're used to in your typical A-level maths textbook, or on A-level maths past papers, for example. Okay, so you don't need to be doing or have done further maths at A-level, although I might suggest that you may be at a bit of a disadvantage doing the MAT if you haven't done any further maths, and it's not because the techniques that are involved in the MAT or that you're expected to use in the MAT are techniques that are typically encountered on the further maths. It's just that those doing further maths may have a bit more experience with problem solving, viewing things in a particular way, using certain techniques in certain ways, and so on and so forth. So that's not to suggest that if you're just doing normal A-level maths that you can't be successful on the MAT. You absolutely can, and you can go on to university to do maths and be highly successful, or computer science or statistics or whatever else requires the MAT. So don't feel that if you're not doing further maths that it's all over, that it's game over, because it's not, okay? It's just you might have to work a little bit harder to prepare for the MAT. So the problems that you encounter on the MAT are going to be typically more challenging. You're going to have a bit more thorough knowledge and understanding of the techniques that you learn about when you do your normal A-level maths. Well worth practicing beforehand with the past papers. I will include in the description to this video a link where you can download the past papers for the MAT, and you can get a feel for the kinds of problems that you're going to encounter on a typical MAT. So to be successful with the MAT, you need to have quite highly developed problem-solving skills. So that's what this video is going to be about, really. So I've taken a problem from one of the past papers for the MAT, the 2014 past paper, and I'm going to be working through the solution, or my solution to this problem. And it is my solution. It's not a solution that I've just taken from the mark scheme or model solution or anything. And the video is not intended to be a model solution to that particular problem. The specific problem and the specific solution to that problem are kind of secondary considerations. The main focus of this video is really the problem-solving process, okay? What I want to do is to try to articulate how my solution developed to this problem, the kinds of things that I was thinking about, maybe the kind of ideas that I had, what worked, what didn't work. The video is going to be a bit rambly in some places, so it's not going to be a quick, snappy sort of video if that's what you're after. If you've got a short attention span, maybe watch another video. I will be going off on tangents, no pun intended, from time to time. So it might be worth taking notes during this video. It might be worth rewatching certain parts of the video, because what I'm trying to do really is to just give you some ideas. So the problem-solving process and your problem-solving skills need to be, as I said, quite highly developed, but it's very difficult to systematically teach problem-solving skills. So just like you can be taught how to solve simultaneous equations in a very step-by-step methodical sort of way, you don't even really need to understand what you're doing a lot of the time, although it helps if you do. Problem solving is completely different. It's a much more vague sort of thing, and it develops in a much more natural sort of way. I can't give you a set of bullet points, do this, do that, do the other, and you'll get your solution to the problem. How you will end up going about solving problems is really down to you as an individual. You've got to learn how you think, and you've got to develop your own strategies. All I can do really is help you. So I can kind of articulate the kinds of things that help me, and maybe you can, from that, get some ideas, and you might want to try things out. So you might see me do something as part of my solution. You might think, oh, I've never seen that technique used in that particular way. Oh, that's interesting. I didn't know you could do that. Okay. And it's things like this, once you start picking up on these ideas and thinking about them and trying to incorporate them into your own problem solving, you will find that your problem solving skills really take off. Okay. So let's get on with the problem. So it's the 2014 MAT, and it's question 2 that we're going to be looking at. So this was a nice little problem. It wasn't overly difficult. There were some challenging aspects to it, but it really, on the whole, it wasn't particularly difficult. So let's take a look. So the information that we're given is that let A and B be real numbers, and that's going to be important. Consider the cubic equation x cubed minus 2bx squared, I think it's minus a squared x minus b squared equals 0, and this is called star. Okay, I'll just check that. So I've got my computer here, so if I keep looking down beneath the camera, that's because that's where the question, it's plus 2bx squared. Okay, so the first part of the problem is, show that if x equals 1 is a solution to star, then, so x equals 1 is a solution, that this implies that 1 minus the square root of 2 is less than or equal to b is less than or equal to 1 plus the square root of 2. Okay, so there's no indication given about how we're to go about this, and this is exactly why you've really got to make sure that you have a thorough understanding of the techniques and the concepts that you've learned about in your A-level course. Okay. So first of all, you need to know what it means for x equals 1 to be a solution. And this is a really important thing, by the way, that so many people overlook. Before you start to really go set about solving a problem, make sure that you understand the data that you're given, that's the information that you're given, and what you're being asked to do. Make sure you understand these thoroughly enough, okay? Because so many times people come to me, my tutees will come to me and they'll say, I tried doing this problem, and I couldn't make any progress with it. And what you find is that they don't, in a lot of cases, they don't actually understand the information that they've been given. Or they don't really understand what they're being asked to prove or to show or whatever, what they're being asked to do. If this is the case, it's going to be very difficult, if not impossible, for you to solve that problem if you don't even understand the information that you've been given. Okay, so before you get to your exams, whether it's an MAT, whether it's your normal maths exams or whatever, you need to make sure that you've encountered a sufficient range of problems, and a sufficient range of problems sufficiently varied and sufficiently challenging so that you've encountered information given to you in various different ways so that you're kind of familiar with it. So there's no real surprises for you when it comes to your exam. So you can figure out what's what in your exam. If at this point, assuming that you're not in your exam right now, which I hope you're not, before you get into your exam, take your time with this stuff. Don't be trying to do everything under exam conditions. You will not develop good problem solving skills if you're trying to race through problems too quickly. You need to take your time. Okay. If there's anything that you don't understand, so for example, if you're trying to do this and you think, I don't really know what it means for x equals 1 to be a solution to star, then you need to try to find out. You need to make sense of that, because otherwise, because that's a critical bit of information, and if you don't fully understand that, it's going to be very difficult for you to make any progress. And you need to take your time with it, even if it means that you've got to go away from that problem for a while and do something kind of related to it, but which is going to kind of give you a better understanding of this bit of information. Okay. If it's in your exam and there's some information that you don't understand and you can't figure it out in your exam, well, at that point it's just too late. You're going to have to do the best that you can. But this is why it's important for you to get plenty of practice before you get near an exam with sufficiently challenging problems, sufficiently varied, on a sufficiently regular basis. Okay, so you've been warned. They've got to be challenging enough problems. So if you're doing basic questions, let's say differentiation, just differentiating functions, and let's say the problems that you're attempting, you tend to be just kind of writing out the solutions without any difficulties, then the problems are too easy for you. You're not making any progress, you're just wasting your time. You need to be encountering problems where you've really got to think, and you've got to give yourself the time to think. Anyway, let's get on with the problem. So when I see x equals 1 as a solution to star, this is already giving me certain ideas about how I might need to interpret that bit of information, how I might need to use that bit of information. And I don't necessarily know at this stage which idea I'm going to go with. Okay, but at least acknowledging the fact that I have ideas is my start point here, I guess. Without any ideas, well, what are you going to do, right? So it's better to have ideas than not have ideas. So x equals 1 is a solution to star. I can interpret this in a couple of ways, right? So one thing that I know this means is that if I replace x in this equation with 1, then the equation will effectively balance. Okay, so the numerical value of the left-hand side here of this equation will be equal to 0. Okay. On the other hand, if I know, for example, x equals 2 is not a solution to this equation, what that means is that if I replace x with 2, then I will get an equation that's false, okay? Because the numerical value of this left-hand side will not be equal to 0. Okay, so it's important that I understand that. Another way that I can interpret this, and this may be useful, it's not the idea that I went with, but what it would also suggest if I think about factor theorem is that x minus 1 is going to be a factor of this polynomial. Okay, that might be something that I may need to consider. Maybe I didn't in this context. I didn't for this particular problem. It's not the direction that I went in, but it could work. It could possibly work. Okay, so x equals 1 is a solution. I understand that as meaning that therefore that 1 cubed plus 2b times 1 squared minus a squared times 1 minus b squared is equal to 0. So 1 plus 2b minus a squared minus b squared is equal to 0. Okay, and now I also might start to get some clues from some of the other info. So this is what I'm aiming for. I might take some clues from that about possible things that might be useful for me to do. If you've been given something to aim for, use it. Okay, you're not always given something specific to aim for, and you've got to figure out for yourself what it is that you want to aim for, what you think is going to be useful. But if you've been given something specific to aim for, use it to your advantage. Okay, so what this suggests to me, because of the b here and the form of what I see here, 1 minus the square root of 2, 1 plus the square root of 2, This suggests to me kind of it's got a quadratic feel to it. Okay, what I'm expecting is that I need to be considering B as maybe part of a quadratic equation, but the inequalities suggest maybe a quadratic inequality. Okay, and that's actually what happens. Okay, let's have a look how. So I can rearrange this. So what do I get? I get b squared minus 2b minus 1 is going to be equal to minus a squared. So we've got to make sure we get this right. Okay, minus a squared. So the information that we were given about A and B are real numbers. So you don't need to be familiar with complex numbers, imaginary numbers, things like that, but you do need to be familiar with certain properties of real numbers. One of those properties is that if x is a real number, then x squared is always going to be greater than or equal to 0. So that means that minus x squared is always going to be less than or equal to 0. So what can I say here? B squared minus 2b minus 1 is going to be less than or equal to 0. Okay? Right, so I've got a quadratic inequality here. So hopefully, as part of your A-level maths course, you've been shown how to solve quadratic inequalities. And it's at kind of times like this that a lot of people kind of give up. And it's particularly if they've got kind of less well-developed problem-solving skills, because what people are often waiting for GCSE and A-level is they're kind of waiting to be told what to do. It's almost like it doesn't register with them what they have here. They've been shown how to solve quadratic inequalities, but it's almost like they can only solve quadratic inequalities when they've been primed to solve quadratic inequalities. So in other words, when it's so obvious that what is in front of them, it's like they're expecting a quadratic inequality to come up to solve, or they've been specifically told, solve this quadratic inequality. Okay, but sometimes when a quadratic inequality comes up kind of out of the blue, even when it's clearly there in front of their eyes, they don't necessarily pick up on it. It's amazing to see. It's kind of bewildering sometimes to see this, but this does happen. So to really give yourself the best opportunity of solving problems effectively, you've got to be able to have the confidence to take the initiative when it comes to using these techniques that you've been given. When you're shown how to solve simultaneous equations, solve quadratic equations, find the equation of a straight line, so on and so forth, these techniques are not ends in themselves. They're means to an end. Okay? You need to understand them as a means to an end. They're something that have been given to you because they're going to make your life easier and they're going to be useful to you when it comes to solving problems. But they can only be useful to you if you use them. And sometimes you won't be specifically told to use them. You've got to make the decision for yourself. And this is part of your development when it comes to solving problems. That you're able to do this, that you're able to take the initiative. So let's have a look. B squared minus 2b minus 1 is less than or equal to 0. So how would I solve this? Well, first of all, I'd consider the equation, quadratic equation, b squared minus 2b minus 1 equals 0. You can solve this in whatever way you feel is appropriate. So I'm going to complete the square. And therefore we get b minus 1 squared is equal to 2. So b minus 1 is equal to plus minus the square root of 2. B is therefore equal to 1 plus minus the square root of 2. And then I'll consider the graph of y equals b squared minus 2b minus 1, based on the information that I've just derived. Okay, so what will the graph of this look like? Again, there's nothing telling me to do this stuff. This is just some stuff that I've got to see is useful to me right now to solve this problem. Okay, don't wait to be told to do stuff. You have to take the initiative. So this is the b-axis, this is the y-axis. So it's a positive quadratic with roots at 1 minus root 2, 1 plus root 2. So I get something that kind of looks like this. All right. Now going back to the inequality, this tells me that I'm interested in those values of b for which b squared minus 2b minus 1 is, if I interpret this geometrically, it's on or below the b axis, the horizontal axis. So where is the graph on or below the horizontal axis? Well, it's between 1 minus the square root of 2 and 1 plus the square root of 2, which is exactly what I need, right? So is this as long as it's clear in your solution, as long as you're clearly communicating where your idea has come from, where your results are coming from, this is what your examiner is going to be looking for. Okay, so your examiner will understand what you're doing here. That you've solved a quadratic inequality. You're solving a quadratic inequality using a graphical solution to do so. So if you conclude from this, that will make sense, okay? So we get 1 minus the square root of 2 is less than or equal to b is less than or equal to 1 plus the square root of 2. Or at least as far as I'm concerned, it makes sense. Now, when it comes to writing out your solution to a problem, you have to decide for yourself how you want to communicate your solution, okay? You have to try to look at what you've written objectively and try to decide whether it's going to be comprehensible to somebody who's trying to read it and understand it. Okay, but don't try to aim for perfection. You just need your solution to be sufficiently clear, your ideas to be sufficiently clear. We're not writing out formal proofs here. You're communicating your ideas, and that is what your examiner on an MAT is really going to be looking at, because your ideas indicate your potential to go on to be successful, to do mathematics or whatever it is that you're applying to do at university. Okay, so even if it's not perfect, it's better. Even if the way that you communicate your idea is not perfect, as long as it's clear enough, and as long as your examiner can understand what you're getting at and how you're getting your results, that's fine. Okay, so that's the first bit done. Okay, just before I move on to the next part, it'd be really great if you could hit the subscribe button and subscribe to this channel. If you find this video useful, give it a thumbs up, give it a like. If there's anything that's not clear, I think there'll be many things that are not clear in this video, but if so, please leave a comment in the comments section, and I'll get back to you as soon as I can and give you some clarification for whatever it is that you're struggling with. Okay, but it would be great if you could just hit the subscribe button. Cheers. Okay, so part 2 then says, show that there is no value of b for which x equals 1 is a repeated root of star. Okay, so show that there is no value of b for which x equals 1 is a repeated root of star. So again, you've got to know what it means for x equals 1 to be a repeated root of star. Okay, this might be where factor theorem comes in kind of useful, or certain ideas involving factor theorem, but not necessarily. Okay, so there's a couple of ways that you could possibly go about this. One is to, if you know that x minus 1 is a repeated root of this, then one possibility is that you've got that this factorizes to x minus 1 squared times by x minus k. Okay, so x cubed plus 2bx squared minus a squared x minus b squared must factorize to something like this. And it might be, by the way, that k is also equal to 1. We're not excluding that possibility. So let's assume that that's true. And what we can do then is expand this out. Yes, we're going to have to expand out 3 brackets, big deal, and match the coefficients. So if expanding out brackets is something that gives you the willies, then, well, you're going to have to get over that, I'm afraid. So you get x squared minus 2x plus 1 times x minus k, and therefore we get x cubed minus kx squared minus 2x squared, so x squared minus 2x squared plus 2kx plus x minus k. Tidy up a little bit. X cubed minus k plus 2 x squared plus 2k plus 1 x minus k. So if this is going to work, what do we need? We need that k is going to have to be equal to b squared. We're going to have that 2k plus 1 is equal to minus a squared. Okay. Now, straight away, we can see that there's a problem here. Or can we? Sorry, I think... sorry, that's plus, isn't it? It's covered up with my red pen. So it's minus, it's 2k plus 1 equals minus a squared. Right, that's better. That's better. So we can see that there's a problem here. Why? Well, if k is equal to b squared, again, b is a real number. So k is going to be greater than 0. Greater than or equal to 0. Okay? So that means that 2k is going to be greater than or equal to 0. That means that 2k plus 1 is going to be greater than 0. Okay? But a squared is greater than or equal to 0. So minus a squared is going to be less than or equal to 0. Well, this is a direct contradiction, because we're effectively saying with this equality that something that is positive and non-zero is equal to something which is non-positive, is negative or possibly equal to 0. This is direct contradiction. So since k equals b squared, 2k plus 1 is greater than 0, and minus a squared is less than or equal to 0. So there is no real value of b, such that x equals 1 is a repeated root. Okay, repeated root to start. So it always helps, by the way, to write out some sort of conclusion, just to kind of wrap things up. So this is one way that you could go about this, that you could show that there's no particular value of b that will allow 1 to be a repeated root of this equation. On the other hand, though, we can also interpret this bit of information in a different way. So if x equals 1 is a repeated solution to this, then if we think about a graph, so a graph of, if we just think about the graph of y equals this bit on the left here, if x equals 1 is a repeated solution, then x minus 1 again is a kind of double factor of this. It's a positive cubic. So we're thinking about y equals x cubed plus 2bx squared minus a squared x minus b squared. It's a positive cubic, and it's going to have a repeated root here. So it's going to look something like that. Okay, potentially. Or it could be further over here, and it might have a repeated root. Another possibility is that we get a repeated root looking something like that. Although, because we've got the minus b squared here, remember b squared is going to be 0, it's going to be positive or 0, so therefore it's going to be really this, the first curve that I drew, okay, because it's going to, the curve is going to go through the y-axis below the horizontal axis, below the x-axis. So it's not going to be this red curve. It really doesn't make any difference, to be honest with you. So once you recognize that, what you recognize is that if x equals 1 is a repeated root, a repeated solution of this equation, then x equals 1 will also be a solution to the derivative of this. Okay, so if we calculate the derivative dy by dx, or the gradient function, we get 3x squared plus 4bx minus a squared. So this is just another possibility, by the way. I'm not saying that this is absolutely how you should go about this, but this is just another idea. So what do we get? When x equals 1, we get dy by dx equals 0. So that means that 3x squared plus 3 plus 4b minus a squared must be equal to 0. And what does that mean? That means that a squared is equal to 3 plus 4b. And therefore a is going to be equal to plus minus, yeah, okay, so a squared equals 3 plus 4b. What did I do then? I made a bit of a mistake somewhere. Plus 4b minus root 2. Yeah, okay, so a squared equals 3 plus 4b. So now if, because we know that b must be between these bounds, that's it. Okay, so b is between these two bounds, 1 minus root 2 and 1 plus root 2. So if we go to one extreme, I don't necessarily like this solution as much, by the way, but I'm just showing it because it is another idea. So if b equals 1 minus root 2, then what do we get? We get a squared equals 3 plus 4 minus 4 root 2, which is 7 minus 4 root 2, which it can be easily shown that this is going to be less than 0, which is a contradiction, right? So square root of 2 can easily be shown to be, for example, less than 3 halves, or 1.5, whatever. So that means that 7 minus 4 root 2, 3, well, actually no, that wouldn't necessarily work. 7 minus 4, okay, well, 7 minus 4 root 2 is less than 0 anyway. No, it's not. No, that doesn't work. Okay, forget it. Huh. No, unless I've made a mistake somewhere along the way, that actually doesn't work. But okay, it was worth a try. This is how it works sometimes. You get an idea, you pursue it, and you see what happens. Sometimes it works, sometimes it doesn't. So the first way that I went about it was that worked. We got the contradiction. The one involving differentiation, unless I made a mistake somewhere. So I'm doing some of this off the cuff. Unless I made a mistake somewhere, then it doesn't seem to work quite so well. Okay, unfortunately. So we've done the second part, and then we're told, given that x equals 1 is a solution, find the value of b for which star has a repeated root. Okay, so we've shown that x equals 1 cannot be a repeated root, but that doesn't exclude other possibilities. So we might use the same kind of idea now, but instead of x minus 1 all squared, we get x minus k squared x minus 1 equals x cubed plus 2bx squared minus a squared x minus b squared. And we expand this out. So x squared minus 2kx plus k squared times x minus 1 is equal to x cubed minus x squared, minus 2kx squared plus 2kx plus k squared x minus k squared, which is x cubed minus 1 plus 2k x squared plus 2k plus k squared x minus k squared. Okay, and that has to be equal to x cubed plus 2bx squared minus a squared x minus b squared. Okay, so what did I do with that? Right, so we get some simultaneous equations. We get, for example, k squared equals b squared, which means that b could be equal to k, or I mean, we can assume. Yeah, okay, I'm going to leave it like that for the time being. We also get that 2k plus k squared is equal to minus a squared, and minus 1 plus 2k is equal to 2b. Okay, sip of coffee time. So what do we get? We get b equals k, or b equals minus k. And for this value of b, given that x equals 1 is a solution, find the value of b for which star has a repeated root. Okay, for this value of b, does the cubic such and such have a maximum or minimum at its repeated root? Okay, so either b equals k or b equals minus k, or maybe it should be k equals b or minus b. Let's do that instead. So k equals b or k equals minus b. So if k is equal to b, plug in that into here, we get minus 1 plus 2b is equal to 2b. And plugging k equals minus b into here, we get minus 1 minus 2b equals 2b. So in this case, we get minus 1 minus 2b equals 2b. In this case, we get minus 1 plus 2b equals 2b. That can't work because we get minus 1 equals 0. That's a bit of a no-no. So here we get minus 1 equals 4b. So b is going to be equal to minus a quarter. Okay, we don't even need the other equation, at least not for the time being. However, actually we are going to need it, because the next part of the problem is, for this value of b, does the cubic y equals x cubed plus 2bx squared minus a squared x minus b squared have a maximum or minimum at its repeated roots? Okay, so and there's different ways that you can go about this. You can either go for differentiation, use second derivative test, which means that you're going to need to know the value of a, or possibly is you can go for a graphical solution. Okay, so we know that it's our repeated root. We've got b equals minus a quarter, and we also know that k is equal to b. And just for the hell of it, let's find the value of a. So in k equals b, k equals minus a quarter, in other words, then minus a squared is equal to twice k, so minus a half, plus 1/16, which is minus 8/16 plus 1, minus 7/16. So a is going to be equal to plus or minus root 7 over 4. Okay, plus or minus root 7 over 4. Is a going to be positive or negative? Actually, it doesn't make any difference whether a is, because it's really a squared anyway that I'm after. So a squared, let's get rid of that. Actually, it doesn't make any difference whether a is positive or negative. We're just interested in a squared, which is 7/16. Okay, so we've got the information that we need. A squared equals 7/16. Get rid of this. So we've got that our factorization is, in fact, x plus a quarter squared times by x minus 1. Okay, x plus a quarter squared times x minus 1. And replacing the a's and the b's over here, we get x cubed minus a half x squared minus 7/16 x minus 1/16. Okay, so we can either think about the graph of this. So what does the graph of this look like? Y equals this thing. We're going to get a solution, a root at minus a quarter, a repeated root there, and 1. And if we draw the graph, because this is going to be a positive cubic, it's necessarily going to look like that. Okay, that's the only way that we can make all of the information work, because notice that the y-intercept is negative. That's the only way that we can make it work. Now, this is kind of okay, presenting a graphical solution, although personally I would go for something a bit more thorough, a bit more algebraic and analytical maybe, which is using the second derivative test. Okay, so if we've got y equals this thing, then we get dy by dx is equal to 3x squared minus x minus 7/16, and the second derivative, of course, is going to be equal to 6x minus 1. So when x equals minus a quarter, just to be sure, when x equals minus a quarter, I want to show that dy by dx is equal to 0 here, because if it's not, if I do my calculation, it turns out that dy by dx is not equal to 0 here, then I've done something really wrong. Okay, something's gone really badly wrong somewhere. But also remember that the second derivative test only applies at points where you know the first derivative is equal to 0. Okay, so x equals minus a quarter, then dy by dx is going to equal 3 times minus a quarter squared minus a quarter minus 7/16. Oh, don't need that. Which equals 3/16 plus a quarter, which is 4/16 minus 7/16 equals 0. That's what I expected. So I at least know that the second derivative test applies at this point. Okay, so when x equals minus a quarter, d2y by dx squared is going to be equal to 6 times minus a quarter minus 1, which of course is less than, I don't care what the specific value is, I just care whether it's greater than 0 or less than 0. What does this tell me? This tells me that x equals minus a quarter is a local maximum value, right? The second derivative is less than 0, indicates presence of a local maximum value, which is exactly what we see from the diagram. So how it's entirely up to you how you present your solution to that particular problem, whether you present it purely graphically or whether you use the second derivative test to do it. You've got to call the shot on that one. I personally would have, I probably would have gone for both, actually. I probably would have drawn a graph which suggests that there's a maximum point here, but then actually go on to prove in a much more definitive way. Okay, but it's entirely up to you. Okay, in my opinion, the more detail you can include, without going to an extreme, the more detail you can include, the more you're showing that you understand these concepts, these ideas, and that you've got the potential to go on to be successful at university doing mathematics. So I wouldn't shy away from doing stuff like this. You're not wasting your time. Okay, so that brings us to the end of the solution to this particular problem. It's taken a little bit longer than I expected, maybe, but hopefully you get the main points of the solution. If there is anything that you want some clarification on, of course, leave a comment in the comments section. I'll be happy to provide some clarification. If you would like to know if there's any way that I can help you, if you're looking for help developing your problem solving skills in mathematics, if you're preparing for a STEP exam, if you're preparing for an MAT, or if you need help with your A-level maths and further maths, feel free to get in touch with me. I'd love to have a discussion with you about what your needs are, what your requirements are. I'd love to help you secure a place at whichever university it is that you're looking to get into, and for you to reach your true potential when it comes to doing mathematics. So feel free to get in touch. I'd love to be able to see if I can help you. Okay, so that brings us to the end of this problem, and it brings us to the end of this video. Well done if you've made it this far. Thanks very much for watching.